Hi, everyone. It's just great to be here. I'm Dr. Jonathan Reichental, and I'm thrilled to be at the Internet of Manufacturing event here virtually online. Whether you're watching this live or in a recording, it's good to have you be part of this, and I hope that I can add value today in the content I share with you. Uh, Again, I'm Dr. Jonathan Reichental. I am an educator, teach at many universities. I create content, I consult, and I'm also an investor in social impact companies. So today I'm going to just give a short presentation on digital twins. And in this presentation, I'm going to cover the basics. If you're not familiar with this topic, this is probably the right session for you. I'm not going to go particularly deep, but I just want to give a high-level overview of, this topic. And I hope you find it fascinating. I certainly do, and many of my students do. And of course, organizations are getting tremendous value from it. Now, I don't think that a presentation or a workshop should stop when the video is over or the presentation's over. So I encourage you to connect with me on Twitter and continue the conversation. Perhaps you have some follow-up questions for me, or you just want to follow the topics that I share very frequently, which range not only about digital twins, but about the fourth industrial revolution, quantum computing, and as you'll see a little later, the future of cities, which is quite a big deal. So there's my Twitter handle for you. So let's start with a little background. You always have to do that when providing the context for a new technology. The world has seen a series of revolutions. In fact, we have seen now 3 major industrial revolutions, and we're entering what appears to be a 4th industrial revolution. And I just want to quickly describe each of those. In this image here, you can see, of course, that to make it relevant, we use the term industry instead of industrial revolution, but we're kind of talking about the same thing. It really is the adoption of industrial mechanisms and new innovation that has propelled and moved humanity forward over the last few hundred years. So back in the 1700s, you get this first industrial revolution, and sort of steam is the big deal, and using then steel to build bridges and railways. About 100 years later, in the 1800s, you get the second industrial revolution, and in this you have things like electricity. Electricity is a really big deal, and that allows for mass production, the manufacturing that we all know about today, telecommunications, air flight, a really transformational innovation that has moved a large part of the planet into an absolutely, completely new day. The third industrial revolution, and I would argue we're still living in it, starts in about the 1950s. And this is really about computers and electronics, ultimately the internet. The third industrial revolution enables all of this scenario that we're in right now, where you are watching me live or listening to a recorded video from your smartphone or your laptop or some other device. Now, we are entering the potential here in the first few decades of the 21st century, what appears to be maybe a 4th industrial revolution. And this revolution is characterized by the intersection of the cyber physical world, bits and atoms. And we have a series of new technologies like artificial intelligence and sensors, and even better materials that's enabling us to build things in completely new ways, to innovate at scale and very rapidly. And we're making breakthroughs. And not only that, we have huge impact with these changes, massive scope, and then fundamentally one of the core definitions of the 4th industrial revolution is the convergence of many, many technologies. And it's really those technologies represent both the physical world and the digital world. And it's this context, it's this background that leads us to this notion of the digital twin. So as I lean back a little bit here so you can see what is a digital twin. So digital twin is, well, it's first of all, it's a virtual replica of a physical thing. So the technologies of the fourth industrial revolution, digitalization, analytics, data, sensors, really super performing computer aided design is allowing us to build virtual replicas of physical things. Okay, this doesn't sound such a breakthrough. Haven't we been doing that for a while? Well, let's take a look at this image here. Now we're in a factory. This looks like some sort of power plant, or some huge machines here for moving perhaps fluids. That would be maybe one of my guesses, perhaps water. And what we're thinking about is adding an additional one of these devices to this this industrial setting. And well, here we can see by simulating a virtual replica or a digital twin of this new device, we can see a lot of new detail about how it might look in this new environment. Well, not just how it looks, of course, how it's going to function, and different areas for our consideration. That there is just a digital twin before we've ever built a single physical thing. Now, I've been talking about this sort of design phase, creating a digital twin first. But the digital twin technology will show up in at least 3 areas of, let's use the broad term, product lifecycle management, or PLM, product lifecycle management. And you've got digital twins showing up in the design phase, and then in the build phase, and finally, when we're operating it. So what might this look like? I mean, this slide alone tells you that the digital twin has remarkable utility in various phases of the either manufacturing process or in building new software systems and other entities. So let's take a look at this image here. Here you have a car, clearly. This car has not been built yet, okay? And so we go ahead and we render this digital twin, this digital replica, this virtual replica. And yeah, again, we've been doing that for a long time, but now we're going to do a few more things. We're actually going to put this through a wide variety of scenarios. We're going to drive this car in snow and in heat. We're going to flood it with storm conditions, and we're going to see what happens. And as we do that, we're going to get really good scenario data or simulation data, and that's going to help inform us about the design. Should we tweak something in terms of its physical design, but also should we use a different material? How did this new paint coating chemistry work on this particular vehicle, for example? So we get to do a lot of work before we've ever built anything with this digital rendering of the car. That's really helpful because we haven't spent too much money, and sure, cars are built this way today. Now, but we can build a whole lot of things this way. We can create digital twins for just about anything, and we'll see some examples here in just a moment. Again, whilst we can create specific devices and units like a car, digital twins are showing up on the manufacturing floor as we think about adding new manufacturing machinery. Here again, you can see what it might look like, and again, we can simulate it, which is cool. We can actually show it working in this environment and analyze the data that creates and tweak so that, again, we get a more refined and optimized solution before we ever build it. Now, when we go ahead and build, we can have sensors. Let me go back to that image just for one moment. We can use sensors in the manufactured environment to ensure that we are getting the results we are desiring, that we can detect things like manufacturing issues and errors as we're developing a new product. And the way in which this is achieved is through the use of sensors. So what we want to be able to do, and this again is another emerging technology in this fourth industrial revolution, is put these low-cost sensors strategically over a physical object, the physical item, and have those sensors pick up a whole variety of data inputs and then provide them to the digital twin so that we can detect those things I just mentioned to you. Now, a neat little example here is the use of digital twins in wind turbines. And so these are kind of hard to maintain and also get up close to once they're in action. So what we can do is, and we're seeing this, is we can put a whole lot of sensors in the what we're calling, as you know, the Internet of Things. Put the industrial Internet of Things sensors on these. They're small, very variable sensors for capturing a whole variety of different inputs, everything from things like heat and vibration and others. And then that, in this case, potentially would use some sort of wireless technology to send that data back to a receiving end. And then we can have the digital twin, in this case, in this imagery, the digital twin tell us what's going on with the wind turbine. Knowing what's happening means we can modify, we can actually even send code back to the wind turbine to optimize its performance. And now you start to see the real high quality applications of a digital twin, particularly in this use case. But digital twins are showing up in much more than just the factory floor or in the design of products. Here you see an example of a hospital, and digital twins have found a role in process improvement. So you can, of course, use a digital twin to create a hospital, but if you want to retrofit an existing hospital, you can do that with sensors, and then from that we can render a digital twin of that hospital and look for all sorts of opportunities, like time to get a patient from an ambulance to an operating room, and all sorts of efficiencies. And it can be sought looking at how a complicated environment like a hospital operates. Digital twins are showing up in our cities. Here, yes, is another example of a building. And in this particular example, we have the physical building that exists in the real world. And we've put, again, a number of IoT devices, Internet of Things devices and sensors around this building to detect all sort of things, all manner of characteristics of this building. Again, it could be things like heat, could be detecting smoke or air quality, temperature, obviously, is a big one, humidity. And here in this console, for example, whoops, on this side, here you can see a variety of measurements that are consumed and projected, if you like, onto the digital twin over the cloud from the physical twin in real time. And that's providing intel for whoever is tasked with monitoring this building. Now, as a person who thinks deeply about and helps cities succeed, I wanted to show you the digital twin of Singapore. And Singapore, the city-state, has invested over $70 million in creating a high quality digital twin of their entire city. This is just one section here, and it's now in use. And here, of course, you have the physical city and you have the digital city now. In the digital city, city leaders and a whole variety of stakeholders can monitor various aspects of how this city is functioning, everything from energy consumption to pollution, air quality, the effects of storms and weather, and even traffic congestion, and understanding how the perhaps public transport here is functioning, whether it's on time or not. So this digital twin gives a broad range of stakeholders a remarkable view of the operations of this entire city. And we're doing the same thing with factories. Here's a tractor manufacturing facility. And it doesn't have to be, we don't have to see the actual manufacturing lines. We simply need the data. And that can also be one way of seeing the physical twin, is by looking at these digital dials. So digital twins don't necessarily have to look like the object you are monitoring. One big point here, I'll give you a chance to see it here. It's great to play with this new technology. Cybersecurity must be a priority, as it should be in all aspects of our digital transformation here in the fourth industrial revolution, but particularly on digital twins. You don't want your competitors or bad nation states robbing or using your intellectual property. So I would say, as you think through this, you must couple digital twins with intense focus on cyber security. So as we look out a little bit, what does the future look like for digital twins? Well, it's an exploding area. Certainly, one of its biggest domains right now is the manufacturing space. And that's why it's so appropriate for attendees at the Internet of Manufacturing Congress here to be able to understand it better. General Electric, as one provider, has hundreds of thousands of assets out in the field that are now have digital twins. But we're going to see digital twin usage used for our own bodies, where we, prior to an operation, a surgery team may create a digital twin of us so that it can practice or evaluate the procedure well before you're actually lying on the operating theater table. So that's it at a very high level. I realize it's quick, but hopefully you kind of picked up a few little nuggets there. Maybe you had some questions or didn't realize its applicability. Pretty broad applicability, and I hope that this was maybe inspirational for you, so you can think more and research the topic in greater detail. I've recently written a book about the future of cities called Smart Cities for Dummies, part of the Dummies series, as you can see here. And you can access it through smartcitybook.com or Amazon or any of your local bookstores, physical or online. And in it, I speak about digital twins in a city context. That's one of the reasons I wanted to share this with you, is digital twins are going to play a big role, not just in manufacturing and in Industry 4.0, but also in a city context. So would welcome you to check out that book. Finally, I just wanted to say thank you very much for spending 20 minutes with me today. Again, I wanted to remind you that if you want to connect with me, ask me questions, or discuss an issue, delighted to do that. Always happy to educate or help you. And you can do that through simply through my Twitter handle here or LinkedIn. You can find me on LinkedIn. I'm very active, or at my own website, which is Reichental.com. So I hope you have an amazing rest of this Congress and conference. And if you're watching on a replay on a video, thank you for spending this 20 minutes with me. It's been a real honor and pleasure, and I wish you good luck in the future. Thank you.